Hello, welcome to Prism Technologies. I am Venkat. This is part 62 of SQL Server video series. In this video, we'll discuss about what to choose for performance, subqueries or joins. Let's flip to SQL Server Management Studio. I have two tables here, TBL products and TBL product sales tables. In TBL products table, I've got around 400,000 and TBL product sales table, I've got 600,000 records. I have inserted this huge amounts of data into these tables using automated SQL scripts. We have discussed about how to do that in the previous session of this video series. If you haven't watched that, I would strongly encourage you to do so before continuing with this session. Now, according to MSDN, in most cases there's usually no performance difference between queries that use subqueries and equivalent queries that are formed using joins. Let's understand this with an example. Let's flip to SQL Server Management Studio. Now let's say we want to write a query which lists the list of all products that we have sold at least once. Let's say I want ID, name and description. So how do we write that query? So look at this. Select ID, name, description from TBL products table, where ID in select product ID from TBL product sales table. So if the ID is present in TBL product sales table, then we know for sure we have sold that product, in which case we are retrieving ID, name and description. Okay, now if you look at this, this query is formed using a sub query. Okay, now let's go ahead and execute this query and see how long is that going to take. So I'm executing now. Look at this, the query is executing still. It's already 3 seconds, 4, 5. It should take around 9 seconds. It's actually taking around 7 seconds. Look at this, how many rows we have. We have around 306,199 rows. In how much time? It took around 7 seconds. Okay, so 7 seconds, and we have 306,199 rows. Okay, now let's see how to form the same query but using joins. Now I want the same result, but I want to do that using joins. So if you look at this here, we are selecting the product ID, name and description from TBL products table by joining with TBL product sales table on the common column. What is the common column? ID in TBL products and product ID in TBL product sales table. And we are using distinct here because, for every match we get a row from the left table, but we don't want duplicates, so we are using the distinct keyword there. So let me go ahead and run this. Actually, let me stop this. We want to clear the query cache. Otherwise, this query cache is going to impact the numbers that we get. Okay, so let me drop this query cache. Okay, so what is this query cache? When we execute a query execution plan will be generated. We don't want that plan to be reused, just to make sure that our performance testing numbers are right. So I'm cleaning the query cache and the execution plan cache here. Okay, so once we have done that, now let's go ahead and run this query and see how long this will actually take to run. So it's executing now. It's already 2 seconds, still executing, 4 seconds. Let's see how long is this going to take. So this has also taken around 7 seconds, and look at that, the same number of rows, 306,199 rows, and that's what we have got using the first query. So here, whether you use subquery or whether you are using a join, it is not really making a difference. Okay, but in some cases, again this is present on MSDN, in some cases where existence must be checked, a join produces better performance. Otherwise, the nested query must be processed for each result of the outer query. In such cases, a join approach would actually yield better results. Let's understand this with an example. Look at this here. Now let's say I want to retrieve all the products which we have not sold at least once. Okay, how do we write that using a subquery? Look at this, we are doing that using a subquery here. Select ID, name, description from TBL products where not exists. Remember the exists function. This exists function will actually return true or false. Okay, when will it return true? If there is, if this query returns at least one row, then it's going to return true. Otherwise, this exists function is going to return false. And look at the subquery here. Select star from TBL product sales table where product ID is equal to TBL products.id. Now if you look at this query, it is a correlated subquery, and we have discussed about correlated subqueries in the previous sessions of this video series. If you haven't watched that, I would strongly encourage you to do so. Okay, now look at this. This query will now have to be executed for every row that is retrieved by the outer query. So in these cases, look at this. According to MSDN, in some cases where existence must be checked, so here we are checking for the existence using exist keyword. And now, you know, here the nested query must be processed for each results of the outer query. In this case, a join approach would yield better results. Let's see if that's the case. So here, since the inner query, that's our subquery, has to be executed for every row that is produced by the outer query, a join would actually produce better results. That's what MSDN says. But let's see what actually happens when we execute this query. Let's see how long it's going to take. Before that, let's clean the query cache and execution plan cache, and let's go ahead and execute this query now. So let's see how many seconds is this going to take. So it's running now. 1 second, 2 seconds, 3 seconds, 4 seconds. So it has taken, the subquery has taken around 4 seconds. Look at this. We have got 93,801 records. Okay, so 4 seconds. And it has taken around 93,801 records. Okay, so that's what are the number of rows retrieved. Now we have an equivalent query but formed using joins. So we are retrieving ID, name, description from TBL products. We are doing a left join with TBL product sales table on the common column, which is ID in TBL products and product ID in TBL product sales table. And look at this, we are saying where TBL product sales dot product ID is null. Okay, now we have discussed about joins and intelligent joins again in this video series. If you don't know how to do that, please watch those videos before proceeding with this video. So this left join with this check where TBL product sales product ID is null, this is going to return all the non-matching rows from the left table, in this case from TBL products table. So we are going to get a list of products that we have not sold at least once. So let me go ahead and execute this query, see how many seconds is this going to take. So it took 1 second, 2 seconds. Look at this. It actually took 2 seconds now. Okay, so the join here actually produced within 2 seconds. And look at this. It took around 93,000. It retrieved around 93,801 rows. Now I'm not sure if we have deleted the cache. Let's go ahead and delete the cache and run that query again, because I don't think I have done that. Okay, let me try this now. And now let's execute this. Okay, look at this now. It's taking 2 seconds, 3 seconds. Okay, so the join has actually executed in 3 seconds, and it has given me the same number of rows, 93,801 record. Okay, now let me again clear the cache. Let's execute the query once again that uses subquery and see what's going to happen. Okay, so 1, 2, 3, and look at this. This time it has actually retrieved those records in 3 seconds itself, though it's a subquery. Okay, actually, I have tested this several times, but though here this query is actually checking for existence, and this query is executed every time for the outer query, it actually produced the same amount of time on my machine. Look at that, 3 seconds, 93,801 records, and even the query that uses joins is producing the same result. Now, but what does MSDN say? According to MSDN, in some cases where existence must be checked, a join produces better performance. Otherwise, the nested query must be processed for each result of the outer query. In such case, a join approach would yield better results. But our test proved that both of the queries are producing the same result and they are taking the same amount of time. Okay, that is because in general, if you look at this, if somebody asks you in an interview which is better for performance, joins or subqueries, in general it's actually joins. Joins are much faster than subqueries, but in reality it all depends on the execution plan that is generated by SQL Server. It does not matter how we have returned the query. Did we use subqueries or did we use joins to write that query? It doesn't really matter, because SQL Server will always transfer that query based on an execution plan. If it is smart enough, and if the SQL Server generates the same plan for both the queries, then we are going to get the same result. And that's what is exactly happening here. Now, though I might have written this query using a subquery, SQL Server has actually transformed it, to produce an execution plan, which is same as that of the query that uses joins. That's why I'm getting the same result. Look at this. Let me run this once again. We get the same result. So I'm going to clear the cache. But if it doesn't produce the same result, then definitely in that case a join will be much better than a subquery. In general, that's the common notion. Joins work much faster than subqueries. Look at this. The subquery retrieved the same number of rows, 93,801 in 3 seconds. And look at the join. But before that, make sure we delete the cache. Okay, and let's run this. This is the query using joins. Look at that, 1, 2, and 3 seconds. Okay, same number of rows. So in this case, the SQL Server is actually generating the same plan for both the queries. That's why we're getting the same result. Okay, now instead of going by theory, okay, somebody says joins are much better than subqueries. Instead of simply going by that theory, in fact, we should actually be testing queries for performance and then tuning them as needed. Okay, so I would say, rather than going by this theory, that joins are much better than subqueries, turn on client statistics and execution plan to see the performance of each option for ourselves, and then let's make a decision. So how do we turn on the client statistics and execution plan? It's very easy to do. In SQL Server Management Studio, all you have to do is look at this button. This is called, when you click on this button, it's going to include the client statistics. And there is another button here, include actual execution plan. When I click that button, I'm going to get the actual execution plan as well. So now if I execute this query, for example, the query that's making use of subquery, I get the result, and then I should also get the execution plan and client statistics. Okay, now how to read these client statistics and execution plans and then make a decision, we'll talk about this in a later video session. Okay. On this slide, you can find resources for ASP.NET, C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.